A train slows down as it rounds a sharp horizontal turn going from 90 km per hour to 50 km per hour in the 15 seconds it takes to round the bend. The radius of curvature is 150 meters. So compute the acceleration at the moment the train speed reaches 50 km per hour and assume that the train continues to slow down as this time at the same rate. So in this problem, the train is changing its speed and direction. So the acceleration vector is just the sum of the tangential and the radial components of the acceleration. Tangential acceleration can be found from changing the speed and elapsed time. For the radial acceleration, that is from the train's speed and the radius of curvature. Since the initial and the final velocity are in kilometer per hour, so we need to convert first the initial and the final velocity for our tangential acceleration. So from 1 kilometer, so that is equivalent to 1,000 meter, and for 1 hour that is equivalent to 3,600 seconds. Okay, so using your calculator you can find for the initial as well as the final velocities of the train. So 90 kilometer and then 50 kilometers, same conversion will be used since we want to get meters per second. So cancel kilometers, cancel hours. Okay. So 25 meters per second for initial velocity, and then for the final velocity, okay, that is 13.8 meters per second. So you observe that the final is less than the initial because there's a slowdown during the turn. Okay, so we know the basic formula for acceleration, the final minus the initial over time. So that is 13.9 minus 25. So that is divided by 15 seconds time. So acceleration, still use your calculator or you can do manual computation if you want. Okay, so that is negative 0.74 meters per second. The final acceleration value is negative 0.74 meter per second squared. Okay, so that is backward. So negative 0.74 meter per second squared is equal to your tangential acceleration. Okay, and then for the radial acceleration, so we use v squared over r. So that is 13.9 for the speed meters per second over the radius, which is 150 meter. So the radial acceleration is 1.9 per second squared. But we're looking for the acceleration vector. So it's a combination of the radial and the tangential using the Pythagorean theorem. So AR squared plus AT squared, then extract the root. So substituting the values for AR and AT, 1.29 squared plus negative 0.74 squared. So that gives you, okay, so using your calculator, so that is 1.49 meters per second squared. So to get the angle, so inverse tan of your tangential acceleration, the absolute, divided by the radial acceleration. So just substitute the A and AR, and using your calculator, you can solve for the inverse tan of your. Then the answer is 29.9 degrees. Okay, here's the solution for the problem. Okay, thank you.